Continuing with derivative applications, these are all related rates problem on this page, 6 through 8. A balloon is being filled with helium at a rate of 4 cubic feet per minute. The rate in square feet per minute at which the surface area is increasing when the volume is 32 pi over 3 cubic feet is. So we're given information about the volume because we see cubic feet per minute. Cubic feet, we know it's going to be volume related. Per minute, we know it's going to be rate related. So we know that this must be referring to dV dt. And it's being filled, so that means this is increasing. So we can say positive 4. Volume is 32 pi over 3 cubic feet. This is a moment in time. And it says the rate at which the surface area is increasing. So we're looking for ds dt. So here are the equations that we may need to use. Volume for sphere is 4/3 pi r cubed, and the surface area of a sphere is 4 pi r squared. So let's go ahead and find each of these derivatives and see if these will help us out. So v becomes dv dt. Remember that with related rates, these are kind of word problems where time is always involved. So when time is involved, we're going to a lot of times going to be using applications of related rates. So we go through power rule. We bring down the 3, keep the 4/3 in front, keep the pi. R cubed becomes r squared. We multiply by dr dt. Every variable gets affected by time. The v becomes dv dt. The r becomes dr dt. So we clean this up to be 4 pi r squared dr dt. For surface area, we also find the derivative. So s becomes ds dt. 4 pi r squared becomes 8 pi r. R's derivative gets applied, so we need to include dr dt. So let's see what we need here. We're trying to solve for ds dt. We need r and we need dr dt. Well, I see a path towards dr dt if we can figure out what r is, right? Because if I can figure what r is, I have dv dt and I can solve for dr dt. Well, if I want to find the radius, maybe this other piece of information can help us out. We know that the volume at this moment in time is 32 pi over 3. So if I know the volume at any moment in time, I can use that to help me figure out the radius at that moment in time. So we can plug 32 pi over 3 in for v. We clean this up, get rid of the 3, and 32 pi is equal to 4 pi r cubed. We divide both sides by 4 pi. We get 8 is equal to r cubed. Take the cube root of both sides, we get r equals 2. So once I have my radius, which is 2, I can replace 2 in for r, replace 4 in for dv dt, and now I can solve for dr dt. So take 4, divide the 4 to cancel it out, divide by 4 pi. This all becomes 16 pi. We divide 4 by 16 pi, it becomes 1 over 4 pi. So that's our dr dt. So that's all the information that we need. ds dt is going to be 8 pi r. Our radius is 2, and then our dr dt is 1 over 4 pi. We reduce, clean this up to be 4 square feet per minute is going to be the rate of change of our surface area. Okay, number 7, we have a circular cone, vertex down. Okay. Radius is 10 feet at the top. We know that the height of this cone is 20 feet, but there's a water level that's always changing. So there's always a changing radius and changing height for that water level. From that information, we can create similar triangles. Or we can create ratios, proportions, because we have similar triangles. So we can say small radius is to the big radius, which is 10, is equal to the small height as to the height of the big triangle. Cross multiply, and I get 10h equals 20r. So let's see what we have here. we know that the height is falling at 1/2 feet per hour. So we know that's dH dt. So dH dt is falling, which is -1/2. The rate in which cubic feet at which water is leaving the reservoir. So we're looking for dV dt. We're looking for the rate at which water is leaving. So if we want to find dV dt, I need to find the derivative, but to find the derivative, there's too many variables going on here. So I'm going to find a way to replace r, since eventually I have information about h and dH dt. So if I solve for r back in this equation, I can say r is equal to 10/20h. 10/20 is 1/2, so h/2. h/2 gets plugged into my volume equation. So I get pi/3 times h²/4 times h. We cleaned all this up. We get pi/12 h³. So now we're ready to find the derivative. Now we're down to 2 variables rather than the 3 that we started with. So every variable gets affected by time. V becomes dV dt. Pi/12 is going to stay. h³ becomes 3h² dH dt. And now we can plug in the information that we've gathered. dH dt is -1/2, so that plugs in. H is 8, so that plugs in as well. And we multiply and clean this up. We get 3 times 64 divided by 24. That reduces to be -8 pi cubic feet per hour. The problem is saying, though, what rate is the water leaving? So we can say that water is leaving at a rate of 8 pi cubic feet per hour. And the negative just indicates that water is leaving and is not entering into the tank. Okay, number 8. 2 cars are traveling along perpendicular roads. We have car A, 40 miles per hour. We have car B, 60 miles per hour. At noon, car A is going to reach the intersection first. And when car A reaches the intersection, car B is still a ways away. It's still 90 miles away from the intersection. So that's at 12 p.m. But we're asking what is happening at 1 p.m. What's happening 1 hour after this moment in time. So 1 hour later, the car A is going to be traveling at 40 miles per hour. And then an hour later, and over that period of the hour, car B is going to be traveling at 60 miles per hour. So if car B is initially 90 miles away and travels at 60 miles per hour, that means he's going to be 30 miles away from the intersection. So our new x value is going to be 30. Car A is going to be traveling for 1 hour from 12 to 1 at 40 miles per hour. So at 40 miles per hour, that means at 1 hour later, this car A is going to be 40 miles away from this intersection. So y is going to be 40. And we can find z, which is the hypotenuse. So a² plus b² equals c². We can also recognize this as a Pythagorean triple. So z is equal to 50. Okay. dx dt is -60 because car B is moving at 60 miles per hour, but it's moving in a way that causes this triangle length to be decreasing. So that length distance is decreasing between car B and the intersection at -60 miles per hour. dy dt, however, is positive because as A is moving away from the intersection, that distance is increasing. So we start out, we know that this is a Pythagorean theorem problem. We say x² plus y² equals z². We find the derivative with respect to time for each of the variables. And now we can just plug in. We have 5 of the 6 variables accounted for. The only variable that we don't have is dz dt. And when we plug everything in, we'll be able to solve for dz dt, which cleans up to be -4. So this distance, 1 hour later, is going to be decreasing at 4 miles per hour, the distance between the 2 cars.